All right, today is Wednesday, May 13th, 2020. This is the Kubernetes CSI implementation meeting. So the main topic for today is enhancements freeze, which is next week, next Tuesday, May 19th. We have quite a number of KEPs to look at and review. I think we're making good progress on all of them, so that's good. I think going down our list of projects for 119, we have a small audience today, so probably skip a lot of stuff. Maybe go down to volume health.
Oh, okay. Volume health. So Nick, he cherry-picked my change to add that dot processing, and that works. So now at least past the CI. So he also pinned. There's somebody else who is interested in helping with the implementation. So he has reached out to this other person. I think we need to implement that in the mock driver. So this other person is going to do that while he's concentrating on adding the changes in the controller and the agent.
Okay, awesome.
Oh, and I updated that cap, so need to review again. Yeah, so now it's with this new format. Okay.
All right, sounds good. Awesome. Then we have snapshots.
Yeah, so I think Shangqian said he cannot join today, but he want me to pin you again for reviewing the metrics.
Yeah, I'm concentrating on the KEPs this
that's
week.
what I thought.
So, because I'm reviewing like, I don't know, more than 5 KEPs. So
Okay.
I probably won't be able to get to the metric stuff till next week.
Okay, I will let him know. Yeah, sure, no problem. Yeah,
I can let him know too, since he technically works for the same company as me. But yeah, okay.
Yeah, okay. Sure.
Okay. Let's see. Besides that, I think
I need to do some. I need to do some more testing with that requeue thing. I mean, but otherwise, that is ready. I think Grant, is he still working on? I haven't seen him pin his E2E test. So maybe he's still working on it. I will ask him and see how he's doing. So, because last time he said he's still working on it, addressing the comment, I think.
Okay, sounds good. Awesome.
I think, this seems like this other person still have not addressed that problem yet. I probably need to try and see. He seems to have some problem with the path. The person who is trying to move the package, to separate the package.
Oh,
yeah,
is like the Go mod or something complaining?
He said some problem. He was saying there was some problem. So I think probably I need to try and see exactly what that is.
Okay.
So, yeah.
All right, awesome. Let's see. Next, we have volume expansion.
Hello, sorry. So we have a call tomorrow to discuss in Kubernetes thing. I spoke with James offline, and he agreed for 2 p.m. call. I have scheduled, and I spoke with Saad. I also have scheduled another call with for CSI community at 2 p.m. tomorrow. I think the 2 items that we need to discuss is obviously I have already a PR open for that deprecates the plugin capabilities offline online, and another item is the read-only handling that we talked about in the last call. I think if node expand volume gets called just after node stage and read-only is set, then it needs to be passed. Read-only flag should be passed to node expand volume. So we want to probably add a flag to read-only flag to node expand volume in that case.
Okay. And on the Kubernetes side, we'll need to figure out which read-only Boolean is supposed to toggle that.
In the CSI side, I'm thinking that this will have that, okay, the read-only flag on node expand volume will be same as node publish one, except it gets passed one call before. And in the Kubernetes side, we'll have to pass basically pvc dot pod dot spec dot volume flag. But the control, if the controller publish itself had a read-only flag, that doesn't get passed to node stage or node publish. So that one is bit up in the air actually. So
Well, what happens if you have two pods?
yeah,
And one says read-only and one says not read-only.
right. So in that case, there will be two calls. One will be read only, and like there will be two different calls from, I think that there will be two different calls from two different parts. One will have read only set, another it will not be set. So yeah, let me just talked about this actually.
Because the node stage is the global path, right? That's shared by that's shared across all the pods.
Yes, ideally, yeah, but we don't have read only flag there, so multiple
Yeah,
pods.
I just mean if, say, like the first pod came in read-only, then the global mount, we make it read-only. And then the second pod comes, but it wants to be writable.
Yeah, so we are not talking about like changing nodes. I was not thinking about changing node stage to have a read-only flag, but node expand volume to have a read-only flag. But I think this distinction, like the two pods are using it, and we try to expand the volume. One has read-only set, another doesn't. Then what does the plugin needs to do? It might be unsafe for the in one case, and it might be safe for one but not safe for another, or in general it will not be safe. So
well, doesn't it depend on, it seems like only the CSI plugin would know that.
what do you mean, Ben?
I've been giving some thought to this, and more and more I'm thinking that as long as node stage results in a writable mount, you can always do a resize safely, no matter how many pods have it mounted, no matter how many of them are read-only, because they're only going to have bind mounts to this thing, right? Like, are there
Assuming
situations where,
assuming you implemented it using bind mounts, I guess.
yeah,
well, okay, but so what I'm trying to figure out is there another implementation that could possibly work where the CSI plugin isn't aware that it's like shooting itself in the foot by doing that other thing? Because it seems to me that you can do the right thing, which is to use bind mounts. And if you do something else, then you can also correspondingly fix your resize code to deal with whatever it is you've done. And it doesn't seem like it should be the problem of Kubernetes to help you there, because it's like there is a way that works, and if you deviate from that, you should be able to fix any problems that you create as a result. I think.
yeah. So
I'd like to hear of a counterexample, because I've been thinking about this, and I'm really starting to come around to this is an easy problem. You know, you just where it gets hard is when you have those read-only PVs where the node state itself results in a read-only mount. Then you're screwed. But that's sort of a different class of problems.
so there's this Chris who came over in one of the calls, and they are what they are saying is that if the volume is read only and the read only doesn't have the, so they don't make any FS mounts in, if the volume is read only, I don't make any FS mounts in node stage because I don't know if it is read only. So they don't, so their implementation is like, don't do FS mounts until node publish, because like they do still implement node stage, but they do, I don't know what else they do in node stage, but the wait until node publish to make it make it's not just bind mount, they make actual mounts and
Okay, but
publish.
But if they do that, then that means they have enough information at publish time that they could have mounted it writable too. And the only thing that they're waiting on is, what does this particular pod want? So what they could do is, if they're doing a resize, also do a writable mount, because they had all the information they needed to do the writable mount. They just chose not to do it. Right?
Wait a second. So can you say that again, Ben? Just a second, sorry.
If they're waiting to do any mount until node publish, it means that they've saved enough information that they could have done a writable mount when they got to the node publish call, if that had been necessary.
Mm-hmm.
And the only key that they were keying off of is, does this particular pod want a read-only mount? So the flag that gets passed in from CSI. So if a resize is required, it seems that they should have access to all of the same information, and they can just do a writable mount if needed.
Yeah. So
and it doesn't matter what else is going on, I think.
yeah, I think that they can. The problem they have is that if the resize gets called before node publish, at that time volume is not mounted. The FS,
Yeah, and they can do a mount that's writable and perform the resize, and then do the unmount, and then go later do a readable mount if that's what the user
but they
wants.
don't want to do any resize at before node publish, by the sound of it. So they can only want to do resize after node publish, where they know that, okay, the volume is read only for sure. That seems like an easy problem to fix too, because they could just return an error if volume has been staged but not published, and they cannot support expansion at that
I don't
time.
understand why they would make that choice, but I don't know. I don't see the value of Kubernetes telling you whether it's read only or not,
Yeah.
because it seems like if that mattered to you, you would already know.
Yeah, let me read only multiple parts and how will it affect talk to him and before the tomorrow's call, and see if there's a workaround. The other thing was like, I remember a little bit. We discussed, okay, we agreed to use volume in use error if the volume is mounted read only and it cannot be expanded read only. That was the conclusion in the past call. But there was one small problem as I was making the CSI spec change. That is the error code says volume in use. It doesn't. So that has to be expanded. I know that error is not an error code, it's a string, and it can be changed. So it has to say volume in use or read only. Volume is read only or in use. So that's a bit iffy.
Okay.
Because
Yeah, I agree with that.
so those are the 2 points that we have for read only handling, and then I think we can hash this out tomorrow in the call.
What do we do in the case where the PV itself is read only? Do we refuse in that case?
Oh, when the controller published as read only?
No, when the PV object
Oh.
has a read only true field, which can only happen if the admin synthesizes the PV object, because the sidecar would never create a PV that way.
Yeah. So I think pv.spec.readonly means that the controller publish is read only.
Yes, but the question is, if you tried to expand one of those, have we defined what should happen?
It should probably fail.
It should probably fail, and I think the CSI driver should know that the volume published is read only. You should be able to figure it out looking at the
Oh
path.
yeah. The controller publish does get a read only flag in that case.
Right.
But that's sort of orthogonal to controller expand. So I wonder if we should always fail, or if there's a weird scenario where you'd want to succeed that kind of an expansion.
You mean which expansion? Node expansion or controller
Expanding like a permanently read-only volume.
And even in the controller.
Like the PV is marked read-only, and somebody says, I want to resize this. Like, Well, that, you know, conceivably there's a world where that can succeed, but like that's a really weird thing to do.
But CSI doesn't have CSI. uh, CSI doesn't have like a read-only volume. Only thing is like controller
Right.
publishes read-only or
Well,
not.
it has the list of access modes, which could only contain read-only access modes.
Yeah, but that's different. That's a relationship to node, right? Hang on.
I don't know. I don't want to get off in the weeds on this one. I wanted
Yeah.
to point out that there's that other weird case, and it would be nice to at least define what our expected behavior is,
Okay.
so we don't have surprises. Like I don't see any reason to allow expanding a permanently read-only volume, because what would the point be? But we should
Yeah.
still think through what the proper error codes are and make sure that you get those error codes.
Yeah. I agree. I was just looking at create volume response, or like the volume object themselves have only thing the access mode. They don't have as such like, yeah, the read only flag. So as you said, it could be like if our access mode is like there's no like access mode says only read only or multi node reader only. So does this mean that like separate from how Kubernetes does it, just from CSI standpoint, does it mean that the volume is read only?
I'm not sure. I mean, I think the list of access modes is a minimum set of required access modes, but you can have more. So if the CO asks you for a read-only volume, you can give it a writable volume, but the CO will never ask for it to be writable. It's
Right.
just it's not saying that it must not be writable. It's saying it must be at least be read-only. That's all that it's a minimum, not a maximum. But then when it comes and says, please, I want to publish this read-only, that is saying I don't want anyone to be able to write to this.
Right. Yeah, but what if the access mode has CO has asked for read only volume, and the access mode is the flag has only single read only, like or single node read only, or multi node read only. So it doesn't have any write mode access mode at all in the volume object. Does it mean that the volume is read only?
It just means that it needs to be single attachable and multi-attachable and at least read-only. It doesn't mean that it can't be writable.
Oh,
The
okay.
list of access modes is a minimum requirement, not a maximum limit.
The reason I'm thinking, okay, is like, I think, is there a way to transfer the knowledge that okay, a PV is read only into CSI, that a volume is read only? Because
But
if you are going to,
yeah, the where it comes in is controller publish. If the volume is read-only on the Kubernetes side, when you controller publish it, the read-only flag will be set to true, and
yeah,
only in that case.
sure, but that is, but for control plane expansion, a volume may not be controller published. So at that point, do we want to permit expansion of a control plane expansion of a volume that is read only?
I thought we had already tackled this by passing read-only in that call as well.
Controller expand volume doesn't have a read only call.
Okay, well that may be the one that needs it more than node expand, because
It has a capability, but yeah, not the read
or
only.
we could leave it out and just let the drivers fail when it's not expandable due to being read-only, and succeed when they can do it, because it's harmless if you do expand it. It's not, you're not hurting anyone. It's just kind of weird to expand something that's not writable.
Right.
So
Yeah.
yeah, I like the approach of leaving the API as it is and just saying, you know what, if you can't do it, fail. If you can do it, great.
Yeah. So yeah, we'll have to expand the condition wording from volume in use to volume in use or read only, or volume, yeah, to handle the read only. And that's all. I think these are the two things that are remaining. we'll also try to get a sign off. I mean, I have already a PR I have for the recovery behavior, and there's like, I think there's concern, like Michelle is not telling me, but there's a concern that I'm not getting a lot of reviews on that one, so I don't know if that's like we want to.
Oh, sorry. That's just because I have too many KEPs to review. So
Okay.
I was trying to get Saad or maybe Jan to review them instead.
Okay, so yeah, tomorrow call I also want to take a final call on that issue, whether it's like, I think that it's worth fixing, but the thing is that like recovering from a failed resize scenario and fixing the quota has the same manual steps. In both the cases, you need to delete the PVC, set the PV as a return. So so that's something we'll discuss this tomorrow. But all right,
I can help you reviewing that, your
awesome,
resizing cap.
awesome. All right. And also I'm working on the delete one, like writing a POC code that if the PVC is deleted using the annotation versus finalizer. So yeah.
Is that enough detail, Michelle? You're on mute.
Oh, sorry. Yeah. Seems good. I think from the Kubernetes side, I think it makes sense. I think we'll need to figure out exactly on the CSI side, like how this will work with all the different possible drivers that we can envision. All right. Okay. Any other topics? I think that's all we have for the projects that we're tracking.
So I had an issue I wanted to dredge out of ancient history, if you'll entertain me.
Okay. Sure.
So a long time ago, there was a discussion about like for CSI drivers that are like use iSCSI. How do we make sure that like the iSCSI daemon is running on the host and things like iSCSI kernel modules are loadable on the host? Because on ordinary operating systems, it's not a big deal to just say, you know what, install the iSCSI stuff and set it up as a prereq. But like in these cloud container optimized versions of Kubernetes operating systems, like you don't have a package manager, you don't have a way to install stuff. And so we were talking about, can you run it in another container? And if so, like how do you communicate? And I don't know where that discussion ended up.
I'm not sure it actually ended anywhere. I think
Okay.
it mostly fizzled.
I'm worried that
as
that's, I
far
mean,
as my
I found a
understanding.
couple of issues and threads, on GitHub. And yeah, it feels like people were pursuing it until they just lost energy, and we all sort of defaulted to just forcing the user to set something up ahead of time. But that sort of rules out running on operating systems that don't have package managers. And then that's starting to be problematic. So I don't know who the right people who the right cast of characters is to resurrect that discussion and try to drive towards an answer again. In particular, I'm interested in the container optimized OS that Google uses. Like there's no package manager there, and there's no obvious way to like install a daemon and load a kernel module.
Yeah, loading a kernel module, I think, would be quite hard.
So I'm sure there's other ones that they're in the same boat. So yeah, I'm trying to figure out like what can be done if you have a CSI driver that you do want to run in an environment like that. And I'm tinkering with things, but everything is unsatisfactory. So
is it just Are there other operating systems besides that, or because if it's
Well,
just
yeah,
like
so for example, like if I want to use Trident, the NetApp CSI driver on GKE, I can use Ubuntu OS underneath GKE and just install the packages and it works fine because Ubuntu has a proper package management system. But if I want to run on COS, it doesn't work because like there's no NFS mount utils, there's no NFS kernel module, there's no iSCSI kernel module, there's no iSCSI daemon or any of that stuff that you would want to use Trident. So we tell our customers, use Ubuntu, but like that's not a sustainable answer. Like, eventually, they're going to
yeah.
want to use
Well,
other operating systems.
I wonder, like, is this just a Google problem? Because if it's just a Google problem, like we could maybe come up with a one-off solution.
Well,
But if this is a problem on other OSs, then it would make more sense to try to pursue something more generalized.
today, for me, it's just a Google problem, but I'm sure that there's going to be other OSs where we run into the same issue. I mean, if you think about it, there's a fundamental problem where on one side there's this pressure to shrink the attack surface and make the operating system under the container under Kubernetes as small and as simple as possible and get all the dependencies out of there. On the other side, if you CSI drivers, the sky's the limit as far as what you can design and what you can implement, but there's always going to be some hook down into the kernel level to implement certain types of storage technologies. And so it's like if you tried to accommodate every CSI driver, eventually you would end up building a general purpose OS like Ubuntu, which is the whole thing you were trying to avoid by shrinking the container OS in the first place. So it's like there's this fundamental tension between simplicity versus making it actually work. And
Yeah.
the inclination
So
seems to be to say, well, if you can put all that other stuff in a container, that's the right way to do it in the Kubernetes ecosystem. And I kind of agree. Like we should be able to put all this stuff in containers. With iSCSI in particular, there's a mess because it's some work in the kernel hasn't been done to make that code namespace aware. But that work is being done gradually, slowly, painfully. But the kernel module problem is a little bit more basic.
yeah, so at least the hack that we do in COS is that we do enable the kernel module, but we don't install the user space tools. So we basically we have a separate installer that runs the user space tools in a shroot, which is basically like almost like running it in a container.
Okay, is there a document that gives an example of that working, or like
No.
what
Well,
the trick
you can
is?
see it. You can see it in the Kubernetes code.
Oh,
You can see it there. That's what we do in Kubernetes to do NFS. But I think you're saying that like the iSCSI D has some, even say pretend like the kernel module is enabled.
yeah,
Like
yeah. If
iSCSI D itself still has problems running inside like a sandbox.
if it, there is a one way to make it work, and they're working on making it more flexible and better. The big problem is like if you do that, then it has to be a singleton. So if for some reason you had two different CSI drivers installed that both needed iSCSI, they would have to share this iSCSI D container resource. Because if they both tried to install their own, which would be the natural thing to do, they would fight with each other and the result would be horrible. So
Yeah, I think at least in cloud.
but that's a problem they're working on fixing.
Yeah. Yeah. I think at least in cloud environments, I wouldn't expect multiple iSCSI drivers running at the same time.
Yeah, it would be a rare thing, but it's the kind of thing that in principle it should work. And if, and eventually someone will try it and it will blow up and we'll have to fix it. So I mean, yeah, so that is a lower priority. If we had a way to just run everything in a container and say, forget about two different CSI drivers cooperating, that might be an easier problem to solve that we could address today. I'm just,
Mm-hmm.
I don't know.
Yeah, you can look. You can take a look at this hacky thing that we do to support NFS.
Okay.
But I think that the right answer is, yeah, run the user space tools in a container, and like I don't know if we can really easily solve the kernel module problem. I think the assumption is we still need to at least enable the kernel module.
Okay, and you said that there's an example in which repo of NFS doing this? Is it like the NFS
Oh no, this is
CSI
in
driver?
Kubernetes. No, this is so
in Kubelet?
the hack that we do today for just the entry NFS is the one I sent in the chat.
Oh, okay. Sorry, I don't have
But
that
like
open.
like say you take the Kubernetes CSI NFS driver, I think, does that one bundle like NFS utils in the container image? I forget.
It would probably should if it, I haven't looked though, so I'm not sure.
If
But
the Kubernetes, if the generic CSI NFS driver doesn't package NFS utils, I know at least like I know of some other NFS CSI drivers that do package NFS utils and RPC bind in the container itself.
yeah, so that's one approach that can work. Again, there's issues if that thing needs to spawn daemons and those daemons need to be kept alive and they're running in a container. But with NFS it's less bad. With iSCSI it's really bad because they're the version of your iSCSI ADM CLI tool and the iSCSI daemon have to be exactly the same because they use a proprietary internal protocol to talk to each other that has no backwards compatibility. So any attempts to put the sort of the utilities in the container means that you have to match the version exactly to whatever container is running iSCSI, and sort of forces you to shift them together, and that makes it a little bit more fragile. I mean, it's still a solvable problem, but
I think once they can solve the issue of having multiple iSCSI Ds installed, then it's feasible to like package it with the driver.
Yeah, and in the meantime, you can just do it and hope you never have another iSCSI driver on the same node. Probably.
Yeah.
Okay. All right. Well, I was hoping that some other progress had been made that I was just unaware of.
Yeah, I don't think so. I can show you in terms of NFS driver starting the RPC bind and NFS utils. I will just put this shameless plug here.
Okay, hold on. The link is not opening. Oh, here it is. NFS Services. Oh, okay. So this is the YAML definition for a daemon set that has some container.
Yeah,
Where's the source? Where's the source for that container?
It's here in the same repo. And you can just see the script, the script that starts the NFS services as well.
Okay, same repo. All right, I'll look around here and see what I can find. Thank you, Michelle.
Yep. Awesome. Any other topics? All right, then we'll end the meeting. Thanks, everyone.
Thank you.
Thank you.
Bye.